Hello everyone, welcome back to my channel, and this is the final video I'll be making on solving quadratic equations, and we'll be using the quadratic formula in this one. So let's first write down the general quadratic equation, or the general form of the quadratic equation, which is ax squared plus bx plus c. Now there is one formula which we can use to solve all and any quadratics as long as they have at least one real root, and that formula is x can be found using minus b plus minus under root b square minus 4ac over 2a. This is the quadratic formula where b is the coefficient of the x term, sign included, a is the coefficient of the x squared term, and c is the constant in our quadratic equation. Now let's try solving a quadratic using quadratic equations. So the first question we'll do is 9x squared minus 6x minus 25 equals 0. Now according to our general form of the quadratic, we know that, let's just write this, plus bx plus c. We can say that a is 9, b is minus 6, and c is minus 25. So now let's just go back to our formula, which was x equals minus b plus minus under root b square minus 4ac over 2a. So x will be minus b, we know to be minus 6, plus minus under root b, we know to be minus 6 whole square minus 4, a which is 9, and c which is minus 25 over 2a which is 9. Now if we solve this, we should get two answers to x, or maybe even one answer. The reason we do plus minus, the reason we write plus minus before the root is because a negative or a positive number, both whole squared, will always give me a positive number. For example, minus 2 whole squared and 2 whole squared both give me 4. So when I'm square rooting 4, how do I know if my answer is minus 2 or 2? So we assume both, or we consider both. So now simplifying this, I get minus minus 6 is just positive 6 plus minus, and inside the square root, minus 6 whole squared is 36, minus 4 times 9 is 36 into minus 25 over 2 times 9 is 18. So x equals 6 plus minus under root 36 minus, so minus 36 into minus 25 is 900. 36 plus 900 over 18. So x equals 6 plus minus under root 936 over 18. So now we can plug this into a calculator and we'll get two answers, or we can just leave it in surd form as well. I think the better thing to do would be to leave it in third form, but I don't think that's in the O-level syllabus, the GCSE syllabus. So let's just solve them as decimal. 6 plus under root 936 over 18 is my first answer. and 6 minus under root 936 over 18 is my second answer. So my two answers are 6 plus under root 936 over 18 gives me 2.03, and the second answer gives me negative 1.37. Let's solve a couple more questions. So the next question, let's do x minus 7 whole squared equals 63. So to solve this question, we'll first obviously need to expand the left side, the whole squared. And I've covered this in my previous expansion video, that the whole square brackets are expanded using the identity a plus b whole squared equals a squared plus 2ab plus b squared. So when we go to expand x minus 7 whole squared, this opens up into x squared minus 2 into x into 7 plus 7 whole squared equals 63. So x squared minus 14x plus 49 equals 63. And the first thing you do when you're solving quadratics or any equation is bring everything to the left side or to the right side and make sure there's a 0 on the other side. So x squared minus 14x plus 49 minus 63. When I bring 63 to this side of the equation, the sign changes from positive to a negative, equals 0. So x squared minus 14x, 49 minus 63 is negative 14, equals 0. Now we know that a quadratic equation is minus b plus minus under root b squared minus 4ac over 2a. So we know a over here, in our case a, let me just write the general equation. So we know that a is 1, we know that b is minus 14, and we know that c is also minus 14. So now if we go to plug this into our formula, we get minus 14 plus minus under root minus 14 whole squared minus 4 into 1 into minus 14 over 2 times 1. So simplifying this, we get 14 plus minus under root 14 squared is just 196 plus minus 4 times minus 14 will give me a positive answer, which is 56, positive 56 over 2. So wait, x equals 14 plus minus under root 196 plus 56, which is 252 over 2. So the two answers I have are x equals 14 plus under root 252 over 2 and x equals 14 minus under root 252 over 2. And now we can just convert this into a decimal, which would be the first one, 14 plus under root 252 over 2 gives me 14.94. Or let's just round it off to three significant figures, which is 14.9. And the second one gives me negative 0.937. Now what's important to know about the quadratic formula is that there may be some equations, there may be some quadratic equations which do not have roots. Now what I mean by that is, what we're doing essentially when we're solving quadratic equations is we're finding x-intercepts, right? So the x-intercepts of this quadratic are these two, or there may be a quadratic like this, or even one like this. These are all x-intercepts which you're able to find. Now if you have a quadratic where the curve is not touching the x-axis at all, in that situation the under root, what's inside the under root will give us a negative value, and in that case there won't be any real roots. So it is possible that when you're using a quadratic equation and you plug it into the calculator directly without simplifying any of this, the calculator gives you an error, and the error most likely will be because whatever's inside the under root is a negative, and there is no square roots for negative numbers, or there is no real square root for negative numbers at least.